Diabetic nephropathy refers to the kidney damage caused by both type 1 and type 2 diabetes. Because of the growing number of people affected by diabetes, diabetic nephropathy is currently the leading cause of end-stage renal disease in most developed countries around the world. Each kidney has millions of nephrons, each of which is served by a tiny capillary bed called a glomerulus. The tiny arteriole that approaches the glomerulus is called the afferent arteriole, A for approaching, and the arteriole that exits the glomerulus is called the efferent arteriole, E for exits. The glomeruli are a tiny cluster of capillaries that are physically supported by mesangial cells. So when blood is filtered, it moves through the endothelium lining the capillary, then through the basement membrane, and then through the epithelium lining the nephron, and finally into the nephron itself, at which point it's called filtrate. Now, the endothelium has pores that keep cells from entering the filtrate, and the basement membrane is negatively charged and repels other negatively charged molecules and proteins, like the protein albumin. Furthermore, the epithelium has a special cell type called a podocyte, which looks like an octopus because it has foot processes that wrap around the basement membrane, which leaves tiny gaps between its octopus-like projections called filtration slits. In diabetes mellitus, there's an excess of glucose in the blood because it can't get into cells. And when blood gets filtered through the kidneys, some of that excess glucose starts to spill into the urine, called glycosuria. In addition, when there's a lot of glucose in the blood, it also starts sticking to proteins in the blood, a process called non-enzymatic glycation, because no enzymes are involved. Because glucose can get through the endothelium, this process of glycation can also involve the basement membrane of small blood vessels, which makes it thicken. The process particularly affects the efferent arteriole, causing it to get stiff and more narrow, a process called hyaline arteriosclerosis. This creates an obstruction that makes it difficult for blood to leave the glomerulus, which increases pressure within that glomerulus. At the same time, the afferent arteriole dilates, which allows more blood flow into the glomerulus and increases pressure even more. High pressure in the glomerulus leads to an increase in the glomerular filtration rate, which is just the amount of blood filtered through per minute. And this is the first stage of diabetic nephropathy, called hyperfiltration. In response to this high pressure state, the supportive mesangial cells secrete more and more structural matrix, which expands the size of the glomerulus. This matrix deposition and mesangial expansion can happen uniformly, or it can result in little nodules within the mesangium, called Kimmel-Steele-Wilson nodules, which are tiny balls of protein. The thickening of the basement membrane counterintuitively makes it more permeable, allowing proteins like albumin through that otherwise would have been filtered out. It makes sense though if you think about our octopus friend again. As the glomerulus expands, the legs of the octopus